Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 7, Learning Target 14. So we're talking about mutually exclusive probabilities. So to start with, what do we do when the probabilities say or? Okay, so that's what we want to figure out first is what do we do when the probabilities say or? If the probabilities say or, you need to add the probabilities. Now on our previous note sheets when it said and, we were multiplying. So for this note sheet we're going to be adding probabilities. Now it's important to remember that when you're adding fractions, you need to have the same denominator. So that's going to become really important. Remember, when you add fractions, you need the same denominator, and once you have the same denominator, you only add the tops. So let's go ahead and let's take a look at some of these examples. So taking a look at number 1. It says a bag contains 8 red marbles, 12 blue marbles, 9 yellow marbles, and 11 green marbles. Find the probability that the marble drawn is either blue or green. Okay, so first let's calculate out how many there are. 8 plus 12 plus 9 plus 11. So you add all of those together and you end up getting a total of 32 marbles. So then first let's find the probability of this first part, the probability of getting a blue. So the probability of getting a blue is going to be 12 out of 32 because there's 12 blue marbles. Then we want to calculate out, we're going to add the probability of getting a green. So there's 32 total and 11 of them are green. So then when we go to add this, you're going to add the top, so we're going to take 12 plus 11, and that gives us 23. Now here's the part where students mess up. The denominator, when you add fractions, stays the same. So it's going to stay as 32. You're not going to add the denominator. You're just adding the numerator. So then you can go ahead and you can divide 23 divided by 32, and that gives you 0.72. So there's about a 72% chance that you're going to draw a blue or a green. Let's take a look at number 2. So it says there are 84 teachers at FHS. Find the probability that a teacher chosen for the Quince teacher is a math or a science teacher. So first of all, I know there's a total of 84. First thing I want to calculate out is the probability of the thing before the or, which is math. How many math teachers are there? Well, there's 12. Then I'm going to add on the probability that it's a science teacher. So again, there's still a total of 84. And how many science teachers do we have? Well, we have 14. So we have 12 over 84 plus 14 over 84. So then you can go ahead and again, you're going to add the numerators. So you're going to take 12 plus 14, and that's going to give you 26. And then again, your denominator is going to stay the same. So you have 26 divided by 84. So you divide it out and you end up getting 0.31. Okay, so 0.31. So there's a 30% chance of that happening, of it being a math or a science teacher. All right, let's go ahead and let's talk about mutually exclusive events. So mutually exclusive events are events that do not affect each other. So for example, if I'm rolling a dice and flipping a coin, those events don't affect each other. So because the two things are separate, they don't affect each other, we can simply just add the probabilities together like we did in problems 1 and 2. So that's what we're working on today. We're just going to focus on mutually exclusive events where the two events do not affect each other. All right, so let's go ahead and let's take a look at these mutually exclusive events. So for number 1, it says, 1 teacher must be chosen to supervise a senior class fundraiser, 12 math teachers, 9 language arts teachers, 8 social studies teachers, and 10 science teachers. So if a teacher is chosen at random, we want to find the probability that it's a language arts teacher. Okay, that's our first probability. Or a social studies teacher. Okay, that's our second probability. So first let's figure out how many total teachers we have. We have 12, 9, 8, and 10. So when you add all of that up, you realize that there are 39 possible teachers to chaperone. Then I want to figure out how many of them are language arts teachers. Well, I see in the original problem there are 9 language arts teachers. So now I've taken care of that first probability. Now I'm going to add the second probability. There's still a total of 39 teachers. Well, how many of them are social studies teachers? That's going to be 8. So again, now I can just add these fractions. So 9 plus 8 is 17, and that's going to be divided by 39. So 17 divided by 39 is going to give me 0.44. So there's a 44% chance that it's going to be a language arts teacher or a social studies teacher. Okay, next let's go ahead and let's take a look at number 2. So we're going to look at number 2 here. So it says there are 4 algebra books, 3 literature books, and 2 biology books on a shelf. If a book is randomly selected, what is the probability of selecting a literature book or an algebra book? So first thing I want to do is figure out the total number of books that I have, which is 4 plus 3 plus 2. So 4 plus 3 plus 2 is going to give us 9 total books. So there's 9 total books. So first thing I want to calculate out is the probability that it's a literature book. Well, 3 of the 9 are literature books. Then I want to calculate out the probability that it is an algebra book. Well, 4 out of the 9 books are algebra books. So now I'm ready to add my fractions. Again, I'm just going to add the numerators, which gives me 7, and then I keep the denominator the same. When you add fractions, the bottom of your fraction never changes. So then we're going to do 7 divided by 9, which is going to give us a 0.78. So there's a 78% chance that we can get an algebra or a literature book. Next, let's take a look at number 3 now. So a card is being drawn from a standard deck of cards. What is the probability of drawing an ace or a face card? Well, first of all, when we're talking about cards, I know that there is a total of 52. So there's 52 total cards in a deck. Okay, so I want to figure out first the probability of drawing ace. So if you look back at your very first note sheet, we talked about how for any given card, there's 4 of each specific type of card. So that means 4 out of the 52 are aces. Then I've now taken care of that probability, so now I'm going to add the thing after the or. So there's 52 total cards. Now I want to figure out how many of them are face cards. Again, going back to that first note sheet, you might want to have that note sheet out while you do your practice sheet. How many of them are face cards? 12. Okay, and that was just given to you by your first note sheet. So now we can go ahead and we can add the numerators. 4 plus 12 is 16, and then we're going to take and we're going to divide that by 62, or 52, sorry. So we're going to do 16 divided by 52, and that's going to give us 0.31. So there's a 31% chance that you draw a jack, king, or queen of any suit or an ace. Last couple of problems here. Let's take a look. That's kind of creepy. Okay, let's take a look at number 4. Mr. Berg has 3 different types of calculators. Graphing calculators, scientific calculators, regular calculators. Okay, and then it goes through and it gives us the different types of calculators that we can choose from. So let's take a look at this now. So how many total calculators do we have? So we need to add 25, 30, and 10. So when you add all those up, you realize that he has 65 total calculators. So we want to figure out the probability that he hands out a regular, and then there should be an or right there, a graphing or a regular calculator. So let's figure out the probability of the graphing. Well, I see that there are 25 graphing calculators, so the probability of it being a graphing calculator is 25 out of 65. Now I want to add the probability of it being a regular calculator. So there's 10 regular calculators. So I'm going to go ahead and I am going to add the regular calculators. So now I can add my numerators. So I'm going to do 25 plus 10. That gives me 35. And again, my 65 is going to stay the same on the bottom. So I have 35 divided by 65. So then when you take and you divide those out, you end up getting 0.54. So there's a 54% chance that Mr. Berg is going to hand you a graphing calculator or a regular calculator. So now I'm going to take and I'm going to grab this guy right here. Let's take a look at this dum-dum sucker problem. So there are 3 different types of candies in the bowl, 6 Reese's, 8 Starbursts, and 10 Dum-Dums. What is the probability of drawing a Dum-Dum or a Reese's? So first of all, how many total candies do we have? We have 6 plus 8 plus 10. So there's 24 total candies in the bin. Highlighting a marker would help. There we go. So there's 24 total candies in the bin. So first thing I want to figure out is how many of them are Dum-Dums. Well, I see that there are 10 Dum-Dums. So 10 out of the 24 are Dum-Dums. So now I've taken care of the first part. Now I'm going to look after the or and I'm going to add that probability. So out of 24, how many of them are Reese's? And it gives us that 6 of them are Reese's. So now I'm going to add the denominators. So 10 plus 16 is going to give me, or 10 plus 6 is going to give me 16. And then we're going to take and divide it by 4. So we're going to divide each of those by 4, and we end up getting, or by 24, sorry, 16 divided by 24, and you get 0.67. Now you probably got, if you were to type this in the calculator, 0.66666666666. Remember, you always want to round to 2 decimal points. So take a look at the third decimal point. Is it 5 or greater? Because then you need to round up. All right, let's take a look at number 6. What is the probability of drawing an ace or a king from a standard deck of cards? So let's start by talking about how many total cards are in the deck, and that's going to be 52. Now I need to figure out, okay, how many aces are in a deck? So of each separate card, there's 4. So there's 4 aces in a deck. Then now I want to calculate out the probability of a king. So how many kings are there in a deck? Well, there's also 4 kings in a deck out of the 52 total cards. So remember, with fractions, denominator has to be the same, and then you add the numerator. So I'm going to do 4 plus 4, which is 8, and I'm going to divide it by the amount of cards, which is 52. So then 8 divided by 52 is 0.15. So there's a 15% chance that you're going to draw a king or an ace. So that concludes your note video today. Be sure to show me your note sheet when you are done. Thanks for listening.